Hello and welcome to the AIM Member Solutions series. I'm Mike Allen and I'm the Member Engagement Manager for AIM. AIM's the global industry alliance for stakeholders of RFID, barcoding, smart devices, and other automatic identification and data capture technologies that support blockchain, IoT, real-time location system applications, and more. Our stakeholders include manufacturers, software vendors, distributors, integrators, resellers, governments, and end users across all industries who depend on accurate, available, and identifiable data. AIM creates standards, promotes community, advocates, and educates, enabling adoption, growth, and interoperability to those who depend on accurate, available, and identifiable data. AIM membership gives you the opportunity to influence the ever-evolving direction of our industry. As a member, you receive early access to industry technical research and information. Most importantly, you gain access to a worldwide network of industry leaders and decision makers to promote and effectively use AIDC technologies. Before we get started, I wanted the audience to take note that you are muted throughout the presentation. But if you do have questions for our presenter, Chris, you can send those by using the Q&A dialog box at the bottom of the screen, and we will try to answer as many questions as we can. Now, I'm pleased to introduce you to our industry expert from AIM member, Printronix Auto ID. Printronix Auto ID is part of the TSC Printronix Auto ID family of innovative thermal printing solutions and offers premium enterprise-level products with a selection of specialized technologies, including barcode inspection and RFID printing and encoding. TSC Printronix Auto ID is a top 5 leading manufacturer of thermal barcode label printers with over 5 million printers installed around the world. All products are designed and manufactured in company-owned ISO-certified facilities and backed by a 2-year warranty. The company prides itself on dedicated product and engineering support and its ability to tailor solutions to fit unique printing needs from small businesses to Fortune 500 companies. Today, I'm here with Chris Brown, who is the RFID Business Development Manager at Printronix. Chris will be discussing encoding a RAIN RFID label with an RFID printer. Chris, take it away.
Hey, thank you, Mike. Thank you, AIM, for hosting the webinar, and welcome, everybody. You will note, if you can see my screen properly, that I am not in PowerPoint presentation mode. I'm going to do the presentation in this mode because I'm going to be bouncing back and forth between some different slides. So I apologize for the marketing lack of polish, but I think we can get through it anyway. So as Mike said, my presentation today is Introduction to Properly Encoding a RAIN RFID Label with an RFID Printer. Myself, I am Chris Brown. I am the, quote, RFID subject matter expert at TSC Printronix Auto ID. I've been in the auto ID industry for close to 25 years now, and we are active members of AIM and the RAIN RFID Alliance. In the lower left there, you can see some contact information for me. Don't worry, I'll show that again at the end in the Q&A section. We have a fair amount of stuff today. It's actually pretty heavy stuff, complicated stuff, and this is really just an introduction to open your eyes to what's going on out there. So I'm going to have to speak pretty quickly to get through things in time. This is the rough agenda here. First, I'm going to go through some concepts and terms, just make sure we're all on the same page. Then I'm going to talk about the possible data formatting standards that you would use to encode a RAIN RFID tag or label. That's really the meat of the presentation today. Then I'm going to go specifically into one data formatting standard, the Gs1 EPC SG-TIN 96. And I'm going to build that up so that we can print and encode it on an RFID printer. Then I'm going to take a look, a very introductory look at another data formatting standard, the ISO standards. We're just going to take a look at some basics there. Then, of course, I have to hit you with the hard sell to buy our RFID printers. And finally, we'll finish up with a Q&A section. So the concepts and terms. We are talking about using an RFID-enabled printer to simultaneously print and encode RAIN RFID labels, also known as tags. But how do I actually format the data to be encoded? So the first term is RAIN. There are many different terms for our kind of RFID floating around out in the world. And one of the objectives of the RAIN RFID Alliance is to unify and simplify all of these terms under the single umbrella simple term of RAIN, or RAIN RFID. So we still get telephone calls from long-time barcode resellers, barcode system integrators, and they might say something like, hey, we have been doing UHF passive RFID for a few years. What's this RAIN RFID? What's the difference? Or another reseller might say, hey, we've done EPC number encoding. How is that different from RAIN RFID? Well, UHF passive, Gs1 EPC, ISO 18000-63, and many other terms are all under the RAIN RFID umbrella. So if you do EPC encoding, you're doing RAIN. If you do UHF passive, you're doing RAIN. Note that RAIN RFID is not NFC RFID, and it's not HF, high frequency RFID. So we're not talking about NFC today. Another little concept to keep in the back of your mind throughout this presentation is that all RAIN numbers must be unique globally. So when you're encoding RAIN tags, RAIN labels, one of the fundamental premises of RAIN is that the number that you encode will be globally unique. What do I mean by a RAIN RFID label or tag? That's this picture in the middle here. Looks just like a classic barcode label, and indeed you do print it just like a classic barcode label, but sandwiched under the face stock is a little RFID portion. There's a little chip in there. So while you are printing the data on the face stock of this label, you are also simultaneously encoding that chip with unique variable data. An RFID printer, that's this picture on the far right, looks and smells just like a classic barcode label printer, except we have sandwiched in there a radio module, and that radio module communicates with and encodes the chips in these labels as they're passing through the printer. Then what do I mean by data formatting? Again, that's really the meat of the presentation today. Well, what I mean is when I encode the data to these chips in these labels, how should I format the data? What data should be in there? In what sequence? What are the allowable characters? Okay. There's a lot of confusion out there in the world about how the data should be formatted when you encode an RFID label. Let's look at the problem that we are starting to see out in the world. The first thing to understand is that just in 2020, there were 21 billion tag chips sold, and that number is growing every year. It is also a generally cumulative number. So every year we get about another 20 and soon 25 billion tag chips floating around out there in the world. If RAIN really takes off, if our kind of RFID really takes off and becomes ubiquitous, we're going to have trillions of tag chips floating around out there in the world. The second part of the problem is that people are encoding these tags, these tag chips, with, in quotes, any unique serial number. Somebody gets an RFID printer, they get a roll of RFID labels, and they figure out how to print and encode the labels, and they say, ooh, this is cool. I can now put in my own numbers. They start doing that. Hey, I want to start tagging my IT assets, my laptop computers in my facility. And so they start printing and encoding these tags and affixing them to their laptop computers. So keep that in mind, that people are figuring out how to encode these tags with data, but they don't know about the proper data formatting. This first big bullet point and the second one lead us to the actual problem. In the RAIN world, we generally call this tag clutter. And tag clutter is further broken down into two specific problems. RAIN flooding, the first problem, is when you have too many tags in a read zone for a reader to process all of the tags in the amount of time that the reader has. Many people think you just push a button and the reader reads all the tags in the read zone. That's not true. That's not how the technology works. The reader actually has to process through each and every single tag sequentially. Okay, so the reader actually needs a little bit of time. In most applications today, the amount of time is sufficient for the number of tags that the reader is seeing. But if we keep in mind that the number of tags is going to explode exponentially, then these readers are going to get bogged down with RAIN flooding. The second specific problem is acid rain. Acid rain is when tags from a different application start getting read by your application. So if we go back to our example where I was tagging my laptop computers for asset tracking and inventory control, everything's working fine. I have 500 laptops in my facility. I can push a button and I can see the inventory of those laptops. I can even see approximately where they are in my facility. But now my employees start showing up to work and they're wearing Nike sweatsuits, and those sweatsuits have RFID tags in them. A FedEx box arrives at my delivery door, and the FedEx box has an RFID label on it, and it has 50 products inside of the box, and they have RFID labels. Okay, so suddenly all these RFID tags are entering my read zone, and some of those could be programmed, could be formatted in a way that is very similar to the formatting that I used for my laptop tags. So one day I push the button and I see my 500 laptops, everything's good. The next day I come into my office, I push the button and I see 503 laptop computers. But 3 of those, 2 are some guy's Nike clothes and 1 is a barcode reader that somebody put a tag on. Okay, so the problem, RAIN flooding, too many tags in your read zone for the reader to process, and acid rain is where you pick up tags from another application and they get confused in your application. Now, the RAIN RFID Alliance is aware of this budding problem. It's not a huge problem yet, but we need to take care of it now. And we're looking at a two-pronged approach to solving this problem. The first prong is what we're going to talk about today, which is making sure that you properly format the data to your tag when you are encoding it. If you properly format the data, then readers out in the field, when they read the tags, they can very quickly select the tags that they are interested in and ignore the tags that they are not interested in. So the first part of the solution is to make sure that we format the tag data correctly. The second part of the solution, which is really another topic for another webinar, is to make sure that the readers are properly reading the tags. That may sound kind of silly, but sadly, there are many readers and reader configurations out there running in the real world that are not reading all of the data on the tag that they should, or reading data elements in incorrect sequences, and so on. Somebody gets the reader set up so it works for your specific application, but as the number of tags starts exploding on us and these new tags start entering the read zone, those readers can get confused very quickly. So it's really this first one, properly formatting the encoded data, that we're going to be talking about today. We're using RAIN RFID. RAIN RFID encompasses really 2 sets of data formatting standards, Gs1 EPC and ISO data formatting standards. This means that when you are encoding your tags, you have a choice between using the GS1 EPC tag data standards, that's what they actually call it, or there's a bunch of ISO standards that you could use. You will note the third option of proprietary. Please do not do proprietary encodings. We will come to that towards the end of the presentation. You can do proprietary, but if you do, make sure to wrap your proprietary encodings in an ISO framework so that readers can quickly select them if they want to, or ignore them if they don't want to see the tags. So this is the big gist of today's presentation. RAIN RFID, you can either go down the GS1 EPC data formatting path, or you can go down the ISO data formatting path. If you are asking yourself, well, gee, Chris, which one should I use? I must say that I'm not here as a consultant. I'm not here to recommend one over the other. Our printers support both. We support both concepts, but there are some points here that'll help you answer this question. The first bullet point is that you may have no choice which data formatting standard you use. Let's say I'm the manufacturer of these Nike sweatsuits and I'm shipping them off to Walmart. I hope it's okay to say Walmart here. I'm shipping them off to Walmart. Walmart may tell me, hey, Chris, if you're going to send us your Nike sweatsuits, they must have an RFID tag on there and the data must be formatted as per, for example, GS1 EPC SG1096. So I have no choice. I have to use the GS1 EPC data formatting. Another example would be, let's say I am an automobile parts manufacturer, and I send my automobile parts to Volkswagen for the car assembly. Volkswagen may tell me, hey, Chris, you need to put RFID labels on the shipping boxes, and you need to encode those RFID labels using the ISO VDA standards. Okay, so I have no choice. It was dictated to me by the application and the environment. If you do have a choice, a few things to keep in mind are that the GS1 approach generally provides more infrastructure. It's a little bit easier to follow and understand. GS1 also has excellent services. They have back-end systems. So GS1 can really help you get set up formatting your data properly. On the other hand, the ISO approach gives you more flexibility and advanced options. So if you really want to do something sophisticated and advanced, you might need to use an ISO data formatting. Today, we're going to focus mostly on the GS1 path. We're going to do, like I said, a sample GS1 EPC SG1096 encoding. So we're starting off down the GS1 path. The first thing you need to do if you are doing a GS1 encoding is set your so-called T-bit to 0. There are probably people here on this presentation who have never heard of the T-bit. In RFID, RAIN RFID tag chips, there is one particular bit that is called the T-bit. T stands for toggle, and it's a bit, so it can be either 0 or 1. If it is 0, it tells a reader, hey reader, the data that follow are formatted as per GS1 EPC standards. Conversely, if it's a 1, it tells the reader, hey reader, the data that follow are ISO standard data. Okay. Note that the T-bit set to 0 is currently the industry standard. That means that the big RAIN chip manufacturers, when they manufacture their chips and deliver them to the companies that eventually make the RAIN RFID labels and tags, that chip by default is 0. So it's set for the GS1 standard. I'm not guaranteeing that, but that is the current de facto standard. Buyer beware. You might want to make sure that you check on that. Also note, another beware here is also note that the RAIN industry may change this default standard from 0 to 1. It's not a political move, it's a technical reason. It's a various collection of technical reasons why the industry may change this. So today it's currently 0, in the future it might be 1. So first thing we've done is make sure that our T-bit is set to 0. The next thing you do in the GS1 world is you select an encoding scheme. That's GS1 lingo that approximately means these tags will be used for what application. And in the next slide, we're going to take a look at a list of the GS1 encoding schemes. The encoding scheme is the name, but it actually gets encoded into your RFID tag as a numeric value called the header. So header is just the numeric representation of your encoding scheme. Based on which encoding scheme you're going to use, the GS1 standards will tell you what data elements are required and what are optional. Here's the slide showing you the current common GS1 encoding schemes that are floating around out there. This is actually a table from the GS1 website. So on the left, you see the name of the encoding scheme. Then the second column from the left, you see the numeric header value. Note that these values are in hexadecimal, okay? So for example, this first one, if you were going to encode a GDTI 96, you would actually encode 2C hexadecimal into your tag. On the far right, you see the typical application for each encoding scheme. Today, as promised, we're going to plow through an actual SGTIN 96. So this is a little cutout from the previous table. The name is SGTIN 96. That stands for Serialized Global Trade Identification Number, 96 bits. It has a header value of 30. That's in hexadecimal again. And the typical application for SGTIN 96s is for serialized, what GS1 calls trade items. I like to think of trade item as product type. For example, 12-ounce can Coca-Cola or 5-liter jug Minute Maid lemonade, something like that. And what you're doing with these SGTINs is you're individually serializing each and every one of those trade items. So we have picked our encoding scheme, which is SGTIN 96. And the first thing we need to encode to the tag is this header of 30H. Let's take a little side step here. And this is a chart, a graphic from some GS1 documents, and it shows you the required data elements for an SGTIN. We are going to approximately go through each one of these elements today and build up our SGTIN. Header, we've already done that. So that's 30 hexadecimal. Then we're going to move on through the list here. I'm going to cheat in the sequence a little bit, but when I do cheat, you will understand why I cheated. So next up should be the filter value. And indeed, here we are, we're going to work on the filter value. So also from GS1's documents and website, for each encoding scheme, they will have some kind of table that will say, hey, for this encoding scheme, you can use these possible filter values. They'll have a list of values, and then they will tell you what they are intended to mean. It helps to understand these filter values by understanding what it's for. And what it's for is exactly as the name says. It is another filter which your readers can use to filter out tags of interest, or excuse me, to filter in tags of interest and filter out tags that are not interesting. Okay. So we already have the T-bit set to 0. We have the header of 30 hexadecimal, and now we're going to put in an extra filter called the filter value. For my example today, I'm going to use 0. Just keep that in the back of your brain. I probably should have used 1, so I did a bad example, but we're going to use 0. But you can see the different values I could have used. And in the case of SG-TINs, the different values are meant to roughly mean different packaging levels. So we have now picked a filter value of 0. Now we're going to move on to the next data element. And if we bounce back to this slide, it should be this thing called partition. But I'm a bad boy, so I'm going to go with the company prefix first. We need to know the company prefix before we can actually get the partition value. So even though the partition value goes into the encoding before the company prefix, we need to know the company prefix first to figure out the partition value. In the GS1 world, company prefixes are numbers that are given to companies, and the numbers come from GS1. GS1 has GS1 US, which is also known as UPC, and they have GS1 rest of the world, which is known as GS1 global. They can have slightly different company prefix numbers. I'm in the United States today, so I'm going to use the GS1 US, the UPC company prefix. The product that I'm actually going to uniquely serialize today is shown here in this picture. It is a 6-pack of Diet Dr. Pepper 500 milliliter bottles. Okay, so this, I'm going to actually serialize uniquely these 6-packs. I'm in the US, so I'm going to go to the UPC or the GS1 website, and I'm going to find my company prefix for my company. My company today is Dr. Pepper 7-Up Incorporated. And the GS1 website tells me that my company prefix is this here, 0780000. Okay. Company prefixes coming from GS1 can be 4 to 12 digits. But for SG-TINs, note that you need at least 6 digits. So if you have 4 or 5 digits company number, you got to throw in a couple extra zeros. I don't actually know if those zeros go at the beginning, the end, or even if this particular one is padded. Let's just pretend that this was straight up a 6-digit UPC company prefix. Okay. So I have my company prefix. It is 6 digits. Now we're going to bounce backwards to the partition value. For the different encoding schemes, GS1 will have some kind of a table that will give us the partition values. If you remember, GS1 company prefixes can be variable or can be a different number of digits. In my case, my Dr. Pepper company, the company prefix was 6 digits. So I look through this table, 6 digits long. And then this table tells me my partition value must be 6. These two numbers happen to be the same, but that's just coincidence. If my company prefix was 7 digits long, then I would encode a 5 as the partition value. You encode this partition value into your tag so that a reader can read the tag and know exactly which part is the company prefix and which parts are the other data. Okay, so we have our T-bit 0, header 30 hexadecimal, filter 0. We have our Dr. Pepper company prefix, And now we have the partition value of 6. Next up, it so happens that for SGTIN rules, you have to put in 1 or 2 0 padding depending on who issued your company prefix. Did GS1 US, meaning UPC, issue your company prefix? If they did, you need to put in 2 zeros. Did GS1 Global issue your company prefix? Then you need to put in 1 0. Note that this padding is not the same as this padding, the company prefix. Okay? This padding for the company prefix may or may not happen. This padding is absolutely required. Okay? Now today, we're in the United States, we're using the UPC company prefix, so we are going to pad my encoding with 2 zeros. Boom. The next thing we're going to do is the item reference. This is a number that the Dr. Pepper company has generated, and this number tells people that this product, this item reference, this trade item, is 6-pack Diet Dr. Pepper 500 milliliter bottles. Okay. If I look at my barcode here, I can actually see the item reference number. It happens to be 00388. Okay. It's just coincidence that it's separated by these separator bars. But in this case, the item reference is 00388. Hang in there, folks. I know this is a little overwhelming. And by the way, you will be able to get a copy of this PDF at the end of this presentation. So we have our item reference, and now we're going to put in the serial number. The SGTIN standards allow us to have up to 12-digit serial numbers with values between 0 and 274 something billion. So even though I can have 12 digits, I cannot have 999 billion. I have to stop at this value here. Okay. I forgot to mention one thing. Back to this padding. SGTIN standards say that the company prefix plus this padding of 1 or 2 zeros plus the item reference must equal 13 digits total. If you remember, I had a 6-digit company prefix, 6. It is a UPC company prefix. That's 2 padding zeros. 6 digits plus 2 is 8 digits. That means my item reference number sure better be 5 digits long to make 13 digits. And if I look back here, my item reference was 00388. 5 digits. Nice. Okay, we've put in our item reference. Now we're going to have a serial number. That is to uniquely identify each and every 6-pack. And now we're going to look at setting this up. I'm going to use Bartender label software in my example. You could use another label software like Nice Label. They'll support this too. But I'm just familiar with Bartender, so we're going to set it up in that. So I've opened up Bartender. I have added an RFID encoding object, and this is the dialog to set the properties of that object and to set up the data. Okay. Here on the left is the list of data elements that I need to figure out and populate somehow. The first one is the header, or my encoding scheme. Well, in Bartender, they have this thing called data type, and I have selected SGTIN 96. By selecting that, Bartender is smart enough, and it will automatically generate the associated header value of 30 hexadecimal. And we will see that in the print code later. So I set up my header by setting the data type. Then I have to set up the filter. That's shown here, and we're going to see these in more detail in a second. You got your filter value, then you got your company prefix right there. Then you have your partition, but it's not over here. That's okay. Bartender is smart enough. Bartender will figure out the partition value based on your company prefix length. Then you have this padding of 1 or 2 zeros. Whoops, that's not over here. So we are going to actually have to manually insert that padding, and we will see how to do that in a minute. I should point out that the RAIN Alliance is working with various label software companies to modernize and improve their interfaces here. So this is how you do it currently, but in the future, it may be drastically different and improved and easier. Okay, so the padding, we're going to have to manually kludge that in there. Then you have the item reference number. Here it is in Bartender. And finally, you have your serial number, and here it is in Bartender. Now, breaking this out and actually looking at the values. So the header, if you remember, I get that from selecting the data type. Then came the filter value. I told you I was going to use a 0 today. Then comes the company prefix. Here I have entered the company prefix for my Dr. Pepper company. Then you should have the padding and the item reference. Bartender has only item reference. So I'm going to stuff my padding in right before the item reference. So here I have entered the item reference 00388, but I have stuffed 2 extra zeros in there in front of the item reference for the padding. Then I have the serial number. This is my first ever 6-pack that I'm going to serialize. I'm going to start with 1. I could start with 0, but I like 1 better. So I'm going to have a serial number of 1. You remember that can be up to 12 digits. So Bartender, fortunately, is smart enough, and Bartender will pad this serial number with additional zeros to give you your full 12 digits. Now here I am in Bartender. I've entered my data, and I'm going to push the print and encode button from Bartender. When I push that button, Bartender will generate this code that it will send to the printer. In this case, I am of course using a Printronix RFID printer. So this code that you are seeing here is Printronix printer language that tells the printer, hey printer, wake up, print a label that looks like this, and encode the RFID data with these data. The portion that is highlighted in blue here is the RFID encoding payload. So that's what I'm going to encode to my tag. Now the data here in blue should be the data that I entered up here. But if I look at the data that I'm actually sending to the chip and to the printer, it's different. Well, what's going on here? Why is this data all messed up? Well, the reason is the data as shown here are in hexadecimal. Okay, so I want to take this hexadecimal data and decode it so that I can see that I have the right data. Do these hexadecimal data correspond to and equal everything that I have set up in here? Well, Gs1 on their website, and there's a link posted there at the top left, they have what they call their encoder decoder tool. So I can go to the Gs1 website and I can put in, I've done it down here at the very bottom, I put in this hexadecimal value that I'm sending to the printer, and the printer will send to the tag chip. I can push the decode button. I don't know where it is here. I can push the button and this decoder tool will unpack it. You can see the green arrows going up and decode it. So the first decoding step here is it has decoded it to show me that it is an SG10 96, meaning a header value of 30 hexadecimal. Yay, that worked right. Then between this period, this decimal point, or this period and this period, we can see 078000. That should be my company prefix for Dr. Pepper Company. Is that what I wanted to encode? Yes, 078000. Looking good. Then between these two periods, I can see the padding and the item reference. 00 padding, 00388 is my item reference. There she blows right there. Okay. And finally, this last number, that's the actual serial number. I can also see in the decoder the filter value that I encoded. I put in a 0 and indeed out pops a 0 here. Good deal, we're working. And then up here, I can see the GS1 company prefix length. So if I used a correct partition value, this should say 6 digits. It does. Everything is good. So we have just set up and printed and encoded an SG1096 on a Printronix RFID printer. Next slide. If you remember, at the beginning, I was yammering on about this T-bit needs to be set to 0. You will notice that in my example, I did not explicitly set that. Bad boy playing with fire. Yes, I did not explicitly set it because number one, I was relying on my tag supplier, my label supplier, and the chip supplier to have it set to 0 by default. That is not a good practice, but that's generally what's happening in the world today. The other reason I didn't explicitly configure it and set it up is because in the available tools out there, like Bartender and so on, it's very difficult to set it up. You can do it, but it's a bunch of deep, crazy dialogues that you don't want to get into. So I did not actually set it. Note this last bullet point. If you remember back to acid rain and rain flooding, in order to avoid those problems, especially in the future, we really need to start explicitly setting the T-bit and explicitly reading it later in the application level. So the trend in the RAIN RFID world is moving towards saying, hey folks, do set the T-bit explicitly. When you're encoding the tags and when you're reading the tags, make sure to actually read the T-bit. Just a little side education here. So the T-bit is part of the PC word, which is a chunk of memory within the EPC memory bank. Okay. It doesn't get encoded as easily, I would say, as the regular EPC portion of the EPC memory bank. You need to use a separate command, but it's within something called the PC word. It can be done, but it's done a little bit differently. Now we're going to take a very quick introductory look at the ISO approach to data formatting. Remember, we have the two basic approaches, GS1 EPC with T-bit set to 0, and the ISO approach with T-bit set to 1. So we've set our T-bit to 1, and keep in mind that the default for chips today is normally 0. The next thing you're going to do after you've made sure your T-bit is set to 1 in the ISO world is you're going to ask, okay, what is my application? In the ISO world, applications are, what's the right word? Well, in the GS1 world, the so-called encoding scheme tells you what application those tags are intended for. In the ISO world, the ISO equivalent of a GS1 encoding scheme is Application Family Identifier, or AFI. So depending on my application, I'm going to use this or that AFI. The ISO people like to put these AFIs into two big buckets for what kinds of applications they are used for. The first bucket is for predefined formal standards where you're going to encode your tags. So for example, I am Delta Airlines and I want to do baggage tagging. If I'm going to do that, then IATA, which has specifications that are tied in with ISO specifications, IATA will say you must use this particular AFI. If I'm doing something like blood bag tagging, which is the biologic items, then the ISBT will tell you you must use this AFI. Okay, so that's the first bucket for AFIs. The second big bucket is where I want to just do general unique item identifiers, UII. So I have a thing, I have an item, and I want to uniquely tag it. The ISO world breaks this bucket down into three smaller little buckets. The first mini bucket is industrial barcode encodings, and this is very common now. What this means is I have a barcode and I want to turn that into an RFID tag, and I want to make sure that it's uniquely serialized. So this first mini bucket is just converting a barcode into an RFID tag and making sure it's uniquely serialized. The second mini bucket they call binary encodings. Sorry, I don't really understand what this is about, so I can't explain that one, but please just be aware that it exists out there. The third mini bucket is for proprietary encodings. Now we come back to proprietary encodings. Okay, you want to do your own encoding, your own data formatting, your own serial number scheme, your own data elements, and so on. Go ahead. You can do it, but if you do, make sure you use at least an ISO tag construction with the T-bit set to 1 and an appropriate AFI. Last bullet point here, note that the AFI gets encoded to the PC word. This is where the T-bit is. So in the ISO world, when people are encoding tags, they automatically must be encoding the PC word. So that allows them to very easily set the T-bit. Okay. So in the GS1 world, the header, aka the encoding scheme, got encoded to the normal, that's not a good term, but the regular portion of the EPC memory bank. In the ISO world, the AFI equivalent gets encoded to the PC word. So different approach there. Here are some very common AFIs that are being used out there today. I should point out that AIM on their website has a complete and official list of the AFIs and the associated applications. I just wanted to show you some common ones here. So like for text-based industrial barcode messages, people are using A1, A2, A3, or AC, okay? For airline baggage tagging, people use the AFI of C1. For my blood bags, BB. And then for proprietary encodings, ISO wants you to use 01, 02, or 03. So that's part of the wrapper that allows readers to later easily select and filter tags of interest and ignore tags that are not interesting. The ISO world then has additional data elements. So we've done our AF, we've set our T-bit, we've got our AFI, and then depending on which AFI you pick, you will have additional required data elements and additional optional data elements. A couple of key data elements that you should be aware of are, firstly, data identifiers, DIs. DIs basically say, hey reader, the data that follow this DI are such and such purpose data. For example, the data that follow this DI are a date in the following format. Another key data element in the ISO world is what they call the DAID, Domain Authority Identifier. This one's a little tricky. In the GS1 world, you have your company prefix, but we know that that company prefix comes from GS1. So I can take just that company prefix and I can go to GS1 and say, hey, GS1, who's this company? And GS1 will tell me, this is Dr. Pepper Company. But in the ISO world, there are multiple entities that can issue these company numbers. Again, on the AIM website, they have a list of these entities that can issue company numbers. Each entity that can issue a company number is identified under ISO standards by the IAC, the Issuing Agency Code. It's a little code. You then combine that IAC with the specific company identification number that this issuing agency gave out. An example issuing agency would be Dun & Bradstreet or the Eurodata Council. So Dun & Bradstreet, they have an IAC, and let's say they issue the number 1 for the Dr. Pepper Company. The DAID is the IAC plus the CIN. That means that somebody who reads the tag with a DAID can find out, okay, I need to go to Dun & Bradstreet and I need to say, hey, Dun & Bradstreet, you gave me a company number 1. What company is that? And Dun & Bradstreet will say, that's Dr. Pepper Company. Okay. So again, a list of these issuing agencies and their codes is available on the web, on the AIM website. And there are more. I'm hoping that we can get somebody to do a presentation on ISO data formattings in the future. It's quite complex and I'm no expert. Getting very close to the end here. I just want to take a look at an encoding using ISO data formatting for a basic serialized product barcode message. So this picture in the lower right, we have some kind of machine part. I don't even know what that thing is. And it happens to be uniquely barcoded. And we want to put that barcode into an RFID tag. So the first thing I'm going to do in my RFID encoding is set the T-bit to 1 for ISO. The second thing I'm going to do is pick an AFI that corresponds to industrial barcode messages. If we look back here, A1, A2, A3, or AC all would work. I'm going to use A1. So I'm going to pick my AFI equals A1. Then I'm going to put in a data identifier. That's going to tell the reader, hey reader, the data that follow are such and such. Here we have top right this picture. It's a bunch of text and it tells me the data identifier of 25S. If I translate this gobbledygook into English, it says the data that follow are a DAID plus unique serial number. That's all this really says here. Okay. So because 25S requires a DAID plus a unique serial number. That then is what I'm going to encode. If we look down here at the memory bank 01, which most people call the EPC memory bank, I can see the PC word portion of it, and I can see the UII or EPC portion of it. Let's ignore these data elements today, but here, the T-bit, I have set that to 1. The AFI, I have set to A1. That 0x means just hexadecimal. So it's A1 in hexadecimal. And then I have the actual data that I am going to encode, which consists of the IAC, which is QC, the issuing agency code, then the company identification number of T110, and then I have my unique serial number portion, which is the remainder. Now a reader can go and quickly select and filter looking for that particular tag. It can find it, and then it can go to some database and look up this number and find out the exact information that it wants about this exact individual part. Last slide here. We have our hard sell RFID printers for every application. So this is our RFID printer lineup: heavy duty industrial, mid duty industrial, and a desktop. I should point out that in terms of RF brains, radio brains, RFID brains, I should say, they're all the same. So they all have the same RFID brains. So they really only differ in the traditional barcode printer differences. For example, what DPI print resolution is available, what print widths are available. I should also point out that the two industrial models, the T6000E and T4000, those are designed to work with on metal tags and other difficult physical tag constructions. So you can cram on metal tags in there and you can print and encode them very well. So those are our RFID printers. From today, the take-home message: start with conscious, I shouldn't say choice because sometimes you don't have a choice, but start with clarity on which data formatting standard you will use when you are encoding your tags, Gs1 EPC or some ISO standard. Do not just do any proprietary tag encoding because you could get it to work. Okay, Mike, back to you for the Q&A. Thank you very much, everybody.
All right, Chris, thank you so much again for your time and some of that information today. Really appreciate it. We still have some time for you to submit some questions, so you can get those to us by sending those via the Q&A option at the bottom of your screen. First question that we have is if we're going to get a copy of this presentation, and I will be sending a PDF version of this. I will send that via email to everyone who has registered to the webinar. So you will be receiving that here in the coming days. Another question we received is, what about protection of the tags being tampered or removed?
Okay, there are sort of two aspects to tag security. The first is the physical nature of the tag. So there are tag constructions where when you try to tear the tag off or peel the tag off, the tag will physically break apart. That really has nothing to do with the data formatting, but that level of security is available. Then there's the level of security in terms of encrypting your data on your tags, adding digital signatures, locking the data, permalocking the data. All those kinds of things are possible. Your chip needs to support it. Your printer needs to support it, but they are possible. It's a huge topic, and I'm not an expert on it, but that stuff is possible.
Another question we received is, can I also encode user memory with your printers? And if so, how much data can I encode?
Okay. Answer is yes. So today I only encoded data to the so-called EPC or UII memory bank. But yes, you can also encode data to the user memory bank, which is a separate memory bank. And with Printronix RFID printers, you can encode up to 8 kilobytes, 64K bits to user memory.
Okay, great. Another question we received is, I heard that Printronix recently released a printer that combines RFID and barcode verification, excuse me. Is this true?
Yes, this is true. Okay, so we just recently released our T6000E RFID printer with integrated barcode verification. So that means in one pass, one print job, you can do your RFID smart label encoding, but you can also verify the barcode quality and data of your printed barcodes.
Great. Another question we received is, what data format is normally used for shipping labels?
Oh, okay. This often depends on the industry. This is one of those that both the GS1 world and the ISO world get used for. So your basic shipping label in the retail world would probably be GS1. But your basic shipping label in the automotive industry is probably going to be ISO. So they both have standards, AFIs, encoding schemes that will work, and they both get used, but it tends to be based on the industry.
Great, thank you. Another question we received is, what are the smallest RFID labels you can work with?
Okay. We usually call this the pitch. That means basically the height of the label. It's about 0.625 inches. We can go smaller than that, but that's our spec. So that means you can have RFID labels that are as short as 0.6 inches. Little tiny labels. That's usually sufficient because you have to have your RFID inlay in the label, and the inlays are about that size minimum.
Okay, great, Chris. Well, it looks like we've ran out of time for today. Really appreciate, once again, your time and insight. Also appreciate the audience for their active participation. I know that there's a few other questions people had. Chris, I know you said you were going to, at the end of the presentation, share your contact information again. So
right down at the bottom there. So
yep,
RFID.
RFID at printronixautoid.com. If you still have questions, please reach out to Chris at Printronix. So thanks again to Printronix Auto ID for their support here today, and always their support of AIM and our initiatives. And just want to thank everyone again, and have a great rest of your day.
Okay, and thank you very much, everybody. I know it's some brutal stuff, but we got to get through it. Okay, thank you, Mike.